Up on the screen right now is a description. Oh, I don't think somebody's at the mic yet. So here's a description of actually how it works. We haven't actually gone through these steps. So do you want to talk through this slide?
We were just, this is just letting us, describing how it worked. We've heard the discussion about the mechanics and things of the lasers and so forth. But again, the average distance we were able to record was something like 385. I think around 385. The dispersion caused the laser beam the footprint to be about 7K at the diameter when they reached the moon, and 20K on the reflected return to us on the Earth. That's why, again, the very important job I had was to maintain a very uniform beam out of this laser under some very sophisticated troubling issues that we were having with the pumping of the laser. And again, typically we were running a TEM, those that may be familiar with how lasers are set up. We were trying to run a TEM00 beam, but for that purpose. Yeah. Next one.
Well, just so it's clear, because we haven't actually talked about what a retroreflector is. There might be some people.
Now, retroreflectors, now in this particular case, Dr. Lassie, excuse me for forgetting his name right now, developed this retroreflector, if I'm not correct on that, Joe. But anyway, the retroreflector that we were using, the characteristics of it was the black lines, where it comes in from the source and returns directly toward it, rather than taking an object course, for example, an incident of normal reflectors that would send it off at some other angle. So this allowed us to collect maximum energy back from the retroreflector directly to us here on the surface. So that was the key to making this work, not so much the laser power, but the fact that the reflector was sent back in a line of sight directly toward us from the object there on the ground. Okay?
Right, and I think there's a set of even like something like 100.
Oh, by the way, and of course in that unit there are 100 retroreflectors with an aperture of about approximately a couple of centimeters in diameter.
And just for sake of context, here is the actual telescope in the dome of the building, and then the laser itself was actually in the basement. Mm-hmm. So it was wired up so that it would end up going into the through the telescope. And I think part of the reason it was in the basement is because there's such a danger of maybe a fire or explosion. They wanted to make sure that if they had to douse it with water, that it would be minimal what the impact would be. Is that a pretty accurate statement?
I didn't think so, but maybe somebody else thought so.
That's what I heard, at least.
My laser was not going to get into that type of trouble.
Okay. You hope. Right.
Well, yeah. Okay.
Right.
Now, you can go back there for a minute to the past. I want to point out, there's Buzz and I have been together for years at seminars like this and talks like this. And of course, he's a great guy. But if you mention anything about the hoax, he punches you.
Yeah, I heard the fellow that he punched famously on that video was on the radio 2 nights ago.
Yeah.
And somebody asked him about the reflector on the moon as proof that we had gone there. And he said, no, that's not true. They were just aiming the lasers at the surface of the moon where it was bright and would reflect a lot.
Oh. Well, I got to speak to Buzz about that next time I see him. Okay. Well, the drop down, of course, I described a little bit of my work at Hughes Aircraft Company. We use lasers, integrated lasers into main battle tank fire control systems in the early 70s. The M1 Abrams, which many of us see in action now in the Middle East War, we developed that fire control system. But again, our problem, and I might mention this very quickly, one of the reasons why we needed to bring lasers to the battlefield, at least in the armored systems, is because the Russians outnumbered us nearly something like 100 to 1 or whatever, some large number like that, in armor. Well, when we were thinking about a fight in Western Germany, West Germany, with these guys coming through what was called a Fulda Gap, we had to have a tank that could shoot on the run. And I spent probably just hundreds of hours down in White Sands, New Mexico, riding in the M1, testing and developing in the development phase of the lasers used in there for ranging. Now, one of the big problems I had initially, once we got the system working, the old tankers who were used to doing the parallax fire control systems, when they saw the laser, you push a button and the range comes back 1,200 meters. They would say, how do you really know that that's the truth? I say, well, if you wait to check it, you'll be dead. How about that? So anyway, we finally got those guys to come into the tanks with us and ride and look at the targets and do multiple sensors, let them know the range was true. Finally now, I guess we've all seen these action. Those tanks are really doing a great job. Now, the other thing we did again is brought directed energy warfare systems to the table. We, of course, one of the systems we worked on did get banned by the, what's it called, the Geneva Convention. So that's the system I'd love to tell you about, but it's classified still yet today. But again, we have lasers in space, of course, now mostly in communications tasks. But again, the military are looking, of course, to use lasers in some weapon technologies. Yeah.
Thank you very much, Seth and Hal.
Yeah. Enjoy.
Terrific.